In this video, I'd like to talk about how to factor higher degree polynomials, and this set of questions that I'm working from come from the Khan Academy website. When it comes to factoring higher degree polynomials, we mean polynomials that have a degree larger than 2. There are three distinct, or three I should say popular methods for factoring. The first one is called factor by grouping, and this technique is really good for polynomials that have 4 terms, like we have here in our first example. Another factoring method that is common for higher degree polynomials is called the sum of cubes or the difference of cubes. Now, with the sum of cubes or difference of cubes, the polynomial will only have 2 terms, and both of those terms have to have nice, quote, nice cube roots. I'll see if we've got any examples that pop up on this page. Now, these 3 methods, if you search for these phrases, factor by grouping, sum of cubes, or difference of cubes, if you search for those on the internet or on YouTube specifically, certainly you'll find lots of videos out there for help on those topics. Here again, this example requires factor by grouping. Now, anytime that I see a 4-term polynomial, my guess is to use factor by grouping first, and if it doesn't work, then I might consider other techniques if I can come up with any, or if I can consider any more. Now, for factor by grouping, that means we're going to group the first 2 terms together and group the second 2 terms together. And we're going to treat these like 2 separate problems. So right off the bat here, I'm going to ignore that second group. And within this first group, I'm going to look for a GCF. That's the only way we can factor 2 terms currently. So x cubed, 7x squared, the common factor is x squared, and after that's factored, we're left with x plus 7. Now I'm going to ignore the first term, or first group, and focus only on the second. And on the second group, I see negative 5x and negative 35. Well, they have a common factor, and I'm going to use the number negative 5 as the common factor. One of the tricks you'll pick up on is that if the leading coefficient is negative, it's often a good idea to factor out a negative number to make things work a little bit more nicely. Now, after I divide negative 5x by negative 5, I'm left with a positive x. And after I divide negative 35 by negative 5, I'm left with a positive 7. And to me, this is a really good sign, and hopefully you notice something here too. If we think that factor by grouping would have worked for this particular polynomial, we know that it would work if this term and this term match. We essentially have a large binomial at this point. We've got a binomial made up of this term subtracted by this term. And since these 2, highlighted in green, are the same, that's essentially a common factor between this term and this term. And so we'll factor one more time by pulling that common factor from those 2. X plus 7 was the common factor. And after x plus 7 is factored from this term, and x plus 7 is factored from that term, the 2 terms that are left over happen to be x squared and minus 5. As it turns out, this binomial pair would FOIL together to make our original polynomial. And I did check that off screen, and it was accepted. Now, the next example is not a sum or difference of cubes like I expected it to be, but it's a good problem to practice nonetheless. Let's think big picture here. We have one term that's multiplying by another term, and since multiplication is commutative, we can reorder those in any way that we want. Similarly, we could reorder factors in any way that we want as well. So let's look at this guy first. It looks to me like it's a standard trinomial, so I'm going to try to factor it using the standard trinomial techniques, which means the leading term is going to be x in both of those binomials. The trailing term in each binomial needs to be 2 numbers that multiply to make 6 that add or subtract to make 1. In this case, 3 and 2 I think would be a good choice, and a positive 3 and a minus 2 would work the best because positive 3 take away 2 is positive 1. And a positive 3 times negative 2 is negative 6. In the second term, here again, we've got a series of multiplications that are occurring. So in this second term, I'm going to look for the factoring that would work for it. Now there's only two terms, so I'm going to argue that a common factor is the best way to factor it. And 2x is the common factor between those two terms. When factored from 2x squared, we're left with 1x. When factored from 4x, we're left with the number 2, and that's positive. So this could be our final answer, and we could leave it that way. However, a nicer way to reorder this is to take any terms that are monomials, like this 2x, and list it first. And then me personally, I like to list my remaining binomial factors in ascending order if possible, especially if they're simple binomials like this. So I'll write x minus 2, then x plus 2, and then x plus 3. That's just how I've always done it, but if I'm not mistaken, Khan Academy will accept either of these. And off screen, this answer was accepted. And so for our final answer, or final problem for this video, I'll just walk through this one real quickly, and then we'll call it quits. It again is not a sum or difference of cubes, but that doesn't mean you won't see them. Make sure that you do practice those and research them on your own in case you need the extra practice. On this one, I'll go ahead and start with a common factor again. That's what we should always look for. And as it turns out, each of these three terms does have a common factor, and it happens to be the number 7 along with an x cubed. So if we were to divide each of these or factor each of these by 7x cubed, and I've got enough room so I might even show that. Divide by 7x cubed, divide by 7x cubed, divide by 7x cubed. That's really what's happening when we're factoring by 7x cubed. Well, this leaves us with just an x squared. This leaves us with a negative 3x to the first power. And this leaves us with a positive 2. So don't really need that x to the first power. I'm pretty satisfied with the GCF that's been factored out. Here, I wonder if that's a standard trinomial. So let's see what happens if we try factoring it using a standard trinomial method. X times x gives me x squared. 2 times 1 gives me 2. But negative 2 times negative 1 also gives me a positive 2. Negative 2 minus 1 gives me a negative 3. So as a factored trinomial, standard trinomial, I think this would be a good solution. With the greatest common factor in front, I think this solution now represents the completely factored form of our original problem. And this solution was accepted by the website as well. So hopefully those techniques work for you, and hopefully they are something that you recognize at this point. If you have further questions, please let me know. Thanks for watching.